Namilosa itinyiko kosalama mkela kukajonde ya Physical Sciences on SABC 1 Matrix Uploaded. Namunta, we are looking at lesson number 37 and we're looking at mechanical energy and moment of a force. Okay, so we'll be looking at those two. Of course, as usual, grade 10 to 12. So you are there, you are a grade 12 learner, you sit there, you take part in this lesson because there are those sections that we are going to do that actually focus on your work as well. Okay, now let's begin, of course, with the grade 10 stuff here. Let's talk briefly about gravitational potential energy and kinetic energy. Now, mainly we've got these two types of energy called the gravitational potential energy and the kinetic energy. Okay, now gravitational potential energy is the energy possessed by an object due to its position above the surface of the earth. Okay, now so objects will around the surface of the earth will have different gravitational potential energy depending on where they are and also depending on their masses as well, because that depends on the mass as well, as we're going to see now. Kinetic energy, on the other hand, is energy possessed by an object due to its state of motion. Now, every moving object possesses kinetic energy. Every object that is stationary has got no kinetic energy, because kinetic energy is energy an object will have due to its motion. Okay, and we're going to see how we find those out. Like I said earlier on, gravitational potential energy depends on the mass of the object as well and the height of the object above the Earth's surface. And from this formula here, we are able to calculate for the potential energy, gravitational potential energy, which is given by mass of the object times the acceleration due to gravity, which you know is given as 9.8 meters per square second. This is a constant, okay? And then times the height where that object is found or is located. Right, so I've been able to explain your M, your G, and the H as well. Now, on the other hand, we have kinetic energy, and I said kinetic energy is the energy possessed by an object due to its state of motion, and therefore this should have something to do with the velocity of the object. And for that reason, we give kinetic energy as equal to half times the mass of the object times the velocity of the object squared. Okay, now let's look at some examples that we may have to find in our assessment tasks, see how we are to approach them when they are given to us there in the form of exams or tests or homework based on what we have just said. Let's look at this one. Calculate the gravitational potential energy of a box of mass 30 kilograms placed on a table 5 meters above the ground. Now we know from the formula that gravitational potential energy EP is given by mass times gravitational acceleration times the height of the object. That would mean the mass here is given to us as 30, so for M we have got 30 times G is 9.8, it's a constant, times the height of the object above the surface of the earth, it is 5 meters above the surface, so times 5. What will that give us? We can quickly make use of our calculator here. 30 times 9.8 times 5. Okay, I hope you are actually calculating with me, having your calculators with you as we work here, because that is the way you learn, that's the way you get used to using your calculator as well, and also gaining your confidence in doing this sort of calculations. This gives me 1,470 joules. Energy is measured in joules, okay? Joules, and the symbol is capital letter J. All right, example number 2, let's have a look at this one. It says a 65 kilogram athlete is running at 4 meters per second on a 100-meter track. Find the kinetic energy of the athlete. EK equals half m v squared. So it's half times mass times velocity squared. So this would mean it's equal to half times what is the mass of the athlete? It's 65. What is the velocity of the athlete? Is 4 meters per second, and then that should be squared. So you have got 4 squared is 16, half of 16 is 8, so you've got finally 8 times 65, and what do we have there? This is 520 joules, okay? EK is energy. It is also measured in what? In joules, all right? So these two types of energy, very important for you to note, very important for you to understand, very important for you to know how to use the formulas as I've just used them now to calculate for the unknown quantities or what you are asked to do. Another thing which is we are going to look at not so long, it's something called mechanical energy, which comes from the two energies. And look out for that. In your textbooks, you can check what it is because it has got something or everything to do with kinetic energy and gravitational potential energy. Let's meet in the next section of the lesson.